Hello ENV 118, I am Joshua Maloney, the supplemental instructor for Professor Etter's Intro to Environmental Science. Welcome to an informational video about narrating data. Our first lab is the Ocean Temperature Lab, in which we begin to learn the lab process and start to show how to narrate data. When you try to influence an audience, as it occurs to the new scientist or student that addresses established scientists, professors, or the general public, your scientific visual explainer must be concise, clear, accurate, and easily understandable. Your message should provide only the primary data to reach this goal, which allows you to balance information and clarity. Narrations often include a dataset's minimum, maximum, and average amount. This can alert the reader to the parameters and where most readings lie within the result. Here is how I narrated a graph showing the temperature data I required during another course. The first graph we have is the forecasted versus atmospheric temperatures. Additionally, water temperature is graphed. The blue line is the weather underground temperature in Celsius. The orange line is the measured air temperature. The gray line is Site A's water temperature, and the yellow line is Site B's water temperature. The maximum forecasted air temperature was 17.78 degrees Celsius. The minimum was negative 8.33. And the average forecasted temperature was 8.13 degrees Celsius. The maximum atmospheric on-site temperature measured was 18.2 degrees Celsius. The minimum was negative 3.2 degrees Celsius, and the average was 11.4 degrees Celsius. The maximum forecasted humidity was 93%. The minimum was 32%, and the average was 48%. For measured atmospheric relative humidity, the maximum measured amount was 53.72%, the minimum was 24.44%, and the average was 39.91%. The maximum CO2 measurement was 51 parts per million, and the minimum was 30 parts per million. This reading was very consistent, and it did not appear affected by the road, which was only feet away. We want to find a compelling narrative, but we do not want to exclude any data that doesn't prove our point. Statistics and graphs can already be misleading, so we want to be as unbiased as we can. I hope this helps explain data and statistics. As always, reach out to me, Professor Etter, or the Tutoring Center for more assistance.